Hi, welcome to lesson 2 of the engineering science course. This time we're going to be thinking about the types of engineer and applying that knowledge to different engineering projects or scenarios. So the main focus that we have is for you to know each type of engineer and what they generally do. How we're going to check to make sure that you've got that is to be able to name all 7 types, which we've done in lesson 1, so you should be able to do that, but this is a chance for us to reinforce that knowledge. The second part will be being able to describe all 7 and what do they actually do. The third part will be able to apply that knowledge to specific engineering projects. That's where in the National 5 course, the questions in the exam every single year expect you to be able to apply this knowledge to a given project that will come up in the exam. So very much this is where we're already hitting exam level work. So first things first. Last week we talked about the 7 different types of engineers, or the branches of engineering that we cover within this course. Can you name them without looking at your notes or the PowerPoint from last week? Try it just now in your head or on a piece of paper. This is just for yourself. You do not need to write this in the class notebook on the team. Once you've done that, try to do it with someone in your house if you can. If there's someone else you can ask to test you, to get you to recall that information. Again, without looking at the answers. If there's still 1 or 2 that you're struggling to remember, this is your chance to try and get them stuck in your head. Okay, so the different types of engineer. There's lots of different types of engineer. The first one we're going to discuss is environmental engineers. I've got a description here that you can read, but I will also read it out to you. This branch concerns itself with protecting life, whether this is people, animals, or plants, from adverse environmental effects such as pollution. Environmental engineers work to improve recycling water and air quality, waste disposal, and public health. Just about every project will have an environmental engineer employed to look and work on the project. It's a very important branch of engineering. The next one's civil engineers. Civil engineers deal with infrastructure. They plan, design, and oversee the construction and maintenance of buildings, structures, and facilities, such as roads, railways, bridges, dams, irrigation projects, power plants, and water and sewage systems. The next one is structural engineers. Structural engineers analyse, design, plan, and research structures, ensuring that a structure is safe and can support the needed weight. They are trained to understand and calculate the stability, strength, rigidity of a structure, ensuring that it will not collapse under certain loads, forces, or conditions. Mechanical engineers concern themselves with anything that moves. They design and develop mechanical devices to complete specific jobs. Chemical engineers deal with the chemical properties of materials and how these can be changed or altered for specific jobs. This could be from coating a metal with something to make it more waterproof and rustproof to making plastic from oil. Electrical engineers. This branch of engineering can be thought of to include not only electronics, but also power generation and distribution, motors, and electromechanical devices. It concerns itself with power generation, transmission, utilization, and measurements. Electronics engineer. Although the name is similar to electrical engineer, it's slightly different. Electronic engineering is about automatic control and the implementation of it. It encompasses analog and digital circuits as well as computer programming. You have had a chance to read all 7 types of engineer. This is a chance for you to take a pause. Do the 7 explanations make sense to you? If one or more than one don't, this is your chance to go over to the teams, and we've got the different channels, the bit where it's got the name for the different classes, and for you to ask a question. Ask, say, what's a better explanation or a clearer explanation of this particular type of branch of engineering. With us doing it there, it means if someone else has already asked the same question, you can just see the answer once instead of the teachers being asked the same questions multiple times. However, if one of the explanations still doesn't make sense, by all means, click on the reply button and ask again, and we'll try and make sure that the explanation is clear. The other thing, which goes back to our learning intention and success criteria, is can you remember each one of these? This is again one of the chances for you to test yourself on it and go back on the slides and say, can I remember that one? If you've got someone else that you're able to ask to test you on it, get them to be tested. Now, you don't need to remember the descriptions we've given you word for word, but you do need to remember the overall explanation of what they do. So, for us getting this information stuck in your head, what we'd like you to do in the class notebook, which is on the team, and the table at the top of the lesson 2 page, which is in the types of engineer section within your own space, what we'd like you to do is write a short description for each type of engineer. I'm not looking for you to copy and paste what was in this PowerPoint. I'm looking for it to be in your own words. This is your description that in future you can just go back to this slide and this part of your notebook and check what did you write here. This is what we'll use for revision when we get to the end of term tests. Okay, so you've got down the different types of engineer and what they do. We now want to think about engineering projects. They're generally split into 4 different stages: the design stage, the implementation stage, the testing stage, and then controlling complex systems. So we'll now explain what those 4 different stages are. So the first stage, the design stage. Engineering projects start with a brief or specification. This is when the client asks the company or the firm to make a solution for their problem. The specification part is the rules, what you must do. And it's really important that the engineers know the exact criteria that they are working to. Engineers take their time to plan out, look at a range of options, do any calculations, draw out a final solution to the problem. It's very much iterations, and they will go back to the client during this stage to check is it correct, and they will also be testing their different ideas that they've come up with to ensure that their solution is going to work. Stage 2 is the implementation stage. Implementation is a fancy word here just to mean the building stage. This is when they're going to create the solution. Now, the important thing to keep in your mind here is engineers, they're the ones that have went to university and got some sort of degree in whichever area it is. So at this stage, they're really overseeing the project and checking that it's going as planned. They'll have other people who have done apprentices that will be the ones that are actually physically making it. But the engineers are going to be overseeing, checking, taking it back to the specification and brief to make sure, yep, this is exactly how we planned it and following the steps from their initial plan. Stage 3 is the testing stage. Once they've got the solution up and running, they need to check that it's working as expected. Again, they'll go back to the brief, the specification, the designs, and say, well, this is what I thought it would do. And then they'll be checking, yes, it does do that. It does meet whatever criteria the project must meet. If there's a mistake, this is a chance to fix it before the final project is signed off and it can be used. So an example of this would be the Queensferry crossing. Once it was made, the bridge was then not open to the public for some time so that they could test it and make sure that it was working exactly how it should. The final stage is one that's referred to in the course as the control and complex system stage. This one is the ongoing. Once a project is finished from the building stage and has been tested, you want to make sure that it's still working as it should. So this is an ongoing thing. This is where engineers would be either employed or returning on a regular basis to ensure the solution works exactly how it should. So an example for this could be like a power station and making sure that is the power station still producing the same amount of power as it was meant to when it was built. Has anything changed or anything not working how it should? That would be really important this for if you consider something like a building or a bridge. Just because it worked when you first made it, you don't want to rely that it's always going to be like that, so you might want to check it. Now, what we would like you to do for this task is go back to the lesson 2 page and you'll see that there's a list of the different types of engineer and then a column for you to pick engineering projects. Now we have a whole list of different examples or different projects that are down below. You can pick a different one for each engineer or you can do the same one for multiple. And then for the 4 stages of the engineering project, we would like you to explain what would that engineer be doing at that stage. So go do that just now in your notebook. Okay, so for the whole point of this lesson, we were thinking about what do engineers generally do, and we were thinking about that against an engineering project. We started off with the goals for you to be able to name all 7. Can you still do that? For the descriptions, the new information, are you able to describe all 7? And then the last one was be able to apply that knowledge to the engineers for the engineering projects. And for that, that's on the table that you completed. Do you feel confident in these 3 different areas? Is there any that you're unsure about? If there are, use the channels, the chat space, the posting wall on Teams and ask for some help. Or go back over your notes or the PowerPoint and see, does it make any more sense to you? Finally, next week. So, next week we'll be planning on looking at the impacts of engineering projects, and we'll be looking at 3 different areas: so social impacts, the economical impacts, and the environmental impacts of different projects. But that will be next week's learning.